Hi, I'm Theo. My full name is Theodore Jiang. I'm from Santa Monica, California, and currently I'm a senior at Palisades Charter High School. So a little bit about myself. Needless to say, I basically spend like a majority of my free time working on these sort of science engineering projects. But with what time I have remaining, I like to draw. I'm also a member of the symphony orchestra, so I play oboe in the orchestra. Oboe is a kind of uncommon instrument, but I like the sound of oboe. I like to think of it as the combination of the singing kind of sound of a trumpet with a mellow kind of reed sound of a clarinet or saxophone. So I like oboe. I spend a decent amount of time practicing oboe at home. I also do 3D modeling. So 3D modeling right now, all I do is like static scenes. I guess you can kind of think of it like a 3D image, but it's static, so nothing's moving. I'm trying to get into animation. I think animation would be really cool, but it's kind of a work in progress, figuring out how to do like character rigging and also just animating things in general. But yeah, in terms of future plans for myself, I'm planning on majoring in biological engineering in college. I'm also planning on doing that as a career in medical research as well. So biological engineering, well, obviously it allows us to engineer biology. So whether that's creating artificial organs for organ transplant, or whether that's creating, like, I guess you can call them biological machines, such as a cell to like specifically target a disease without side effects. And that's actually one of the large problems in medicine today is side effects. So then segueing into my current project, MeFormer, before you can engineer something, you need to understand it. So before you can code something, you need to understand the coding language. And the coding language of life is genes and the protein sequences that they code for. And so that's kind of the goal of MeFormer, is to improve our understanding of how the genome works. So MeFormer is a language model. It's a language model that utilizes the transformer architecture combined with convolutional neural networks. And it basically aims to, so the current state of MeFormer aims to target one specific component of the genome, and that is genetic variation and how genetic variation affects disease. So MeFormer inputs a protein mutation, and it essentially predicts what is the probability that this protein mutation will cause some sort of cancer or some sort of disease. And in pathogenicity prediction, which is what this is doing, it shows pretty promising results. It outperforms or matches a variety of existing methods, including some of the most recently developed and best performing methods, some of which also use deep learning. And so hopefully in the future, I hope that MeFormer will give us a more comprehensive understanding of how the human genome works, as well as how we might be able to take advantage of that to fight diseases. And with a more comprehensive understanding, it'll have significant implications for essentially the entirety of medicine, whether that's from disease prevention to diagnosis, to development of new treatment technologies, to also development of new drugs. Thank you.